right, so looking at these two eggs, I wanted to just go over a few of the anatomical features of a chicken egg. So this one obviously is hard boiled, so the albumin here is all hard in there. But you can see what was important here is you can see that there's an air cell right there, basically a gap between the eggshell and the egg itself. If I zoom in on it, I'm sure that you can see it there. That air cell is actually a space between two layers of this membrane. So this is the decalcified, this is the bouncy egg. It's been decalcified by sitting it in vinegar overnight. And this egg was just like this one, except after it decalcified, I then put it in water and you can see it swells up because I used it for the osmosis video. So looking at this outer membrane here, that is two different membranes, the inner and outer shell membrane. And when the egg is first laid, it's very warm, and so those two membranes are pressed together the way they are now while this egg is swollen. But when the inner egg becomes cooler, the shell remains hard and in position, and the inner membrane pulls away from the outer membrane, which creates that air cell, which is great for gas exchange if there's a growing embryo in there. So I wanted to go ahead and break this membrane. I don't know if I can do it by bouncing it. I might have to actually pierce it, which is hard while I'm holding the camera. Not sure. Whoop, bloop, there it went. So there is my inner and outer membrane, both contained together. And then what else I see here is I have definitely this like runny layer around the outside that's very fluidy. Now I have some water in here because of the osmosis experiment, but there is actually two layers of albumin, and one is thick and one is thin. And higher quality eggs usually have more of the thick albumin around it. A few other things that you can see here include the chalza. So the chalza is this sort of whitish structure that actually there should be one on each side, and it kind of helps suspend that yolk in the center of the albumin. You can also see the yolk, and the yolk is all held together by what's called a vitelline membrane. And humans make a yolk sac for a little bit, and they have that same vitelline type membrane around it. You know, if you've ever made an over hard egg or even over easy egg, that you can rupture that and then the yolk will flow out. And then this, I love the way this broke because you can very clearly see here the germinal disc, or sometimes it's called the blastoderm. This is the area that would become the developing chicken if in fact this egg was fertilized. So that germinal disc provides entry to sperm, and it holds within it the chorioallantoic membrane. And in the human, those two membranes are separated, but they're fused together in the chicken and highly vascularized. And sometimes that membrane, which is abbreviated the CAM, is used in research, which we're going to talk about a little bit later. But those are the basic components of the chicken egg, and all of those are surrounded and protected by the calcium carbonate shell that we dissolved off using vinegar. And that albumin is a great source of protein. I should also say the albumin is a great source of protein. The yolk is a great source of fat, minerals, and vitamins. And the areas of the yolk are not all the same fat concentration, which is why sometimes you'll see a little bit of a lighter shade in the center of a yolk, and that's because the fat content there is a little bit different than it is in the outside area of the yolk. All right,